Number 19 is a deposition question, a lot like one we did earlier in the WebAssign, except for it's kind of going backwards. Normally we would find out how much time we left the current on in seconds, and we do this series of conversions using a train track, using a lot of the conversion factor that I've drawn down here at the bottom, like Faraday's constant, how many moles of electrons relate, and remembering that an amp is a coulomb per second. So we would kind of go through this conversion where we had amp conversion, a Faraday conversion, a mole of electron conversions, and then just simply moles to grams. And we could figure out the answer. In this case, we're essentially going backwards. But we're going to stop before we get to time because they want amps. And you remember that an amp is a coulomb per second. So when you draw your train track out, and you're being very good about canceling units, in each spot like this, if you have a coulomb on top and a second on bottom, you've got the answer. So that's what I'd recommend. So start with the 2.20 grams and start working your way backwards. I would save this because I think you're going to put that on bottom. That's going to be the seconds. So essentially, if you get back to coulombs, you can divide it by that time in seconds. So start with 2.20 grams, and you're probably going to want to convert grams to moles first. And you remember that it is copper metal, so that should make figuring out the grams pretty easy. When you do the mole ratio, you remember it's going to be 1 mole of copper, and we got to look at how many moles of electrons. That should be an electron. And the hint is that it's copper sulfate. Copper sulfate has a charge of +2, so it's going to be 2 moles of electrons per mole of copper, and so that'll kind of get you through the next couple steps. Then you're going to need Faraday's constant, and then you should be able to get back to coulombs and divide it by that time.